Alright, here we go with another lesson for today. This section's on, sorry, this video's on section 13.4, which is evaluating inverse trig functions. Should be pretty short since we already kind of discussed inverse sine, inverse cosine, inverse tan. He had a video on it, we did some discussion on Friday, so we could just go straight to some examples here. Then there'll be some questions on the Google Docs form, and then we'll do some practice on this on Monday. So we'll start with the first problem. What is the measure of the angle theta in a triangle shown below? So this is example 3 on page 877 in the book. Obviously, I don't have a triangle here, so I'm going to draw one right now. I could have made one on PowerPoint, but I just didn't feel like it. So here we go. Here's the triangle. So you're asked to find theta. So what you need to do is, what trig function, you want to ask yourself the following: what trig function relates 6 and 11 given theta's location? So notice how 6 is adjacent to theta and 11 is the hypotenuse. So we want to use cosine theta. Cosine theta equals 6 over 11. So it means that theta will equal the inverse cosine of 6/11. Now in this case you need to use a calculator. Degree mode is preferable, and I would specify if I did prefer a mode for you to be in. So the degree mode is preferable because we're talking about angle of a triangle. So make sure your calculator is in the right mode. Inverse cos of 6/11, and we get 56.944 degrees. And I like to go to 3 decimal places. So pretty easy problem. In class on Monday, we'll start dealing with word problems where you might be like standing 20 feet away from a building, and the building might be 50 feet high. What is your angle of elevation? You'll see those kind of problems on Monday. So, but it involves the same kind of stuff here. Now, number 2 is a little bit tricky. So here you have to solve the equation sine theta equals -5/8, where theta is between 180 and 270. This is example 2 on page 876. So right now we know theta is going to equal the inverse sine of -5/8. And if I use a calculator, inverse sine of -5/8. Now hopefully you remember that the default range when you're doing a problem like this for inverse sines would be between -90 to 90. So since sine's negative, I expect my answer to be a negative degree. So I get -38.682 degrees. However, -38.682 degrees is not in between (180 degrees and 270 degrees. So we kind of have a problem here. So here's what you do. Draw the angle. So that right there is -38.682 degrees. Okay, pretty simple stuff. Now this is Q3. So changing colors, this is what we want. So if you think about it, that has to be (38.682 degrees. So what we're looking for is going to be 180 degrees plus 38.682 degrees, which will be 218.682 degrees. So this right here this is equivalent to negative 38.682 degrees when taking sine of theta. So it's a little bit tricky, and I probably have to explain it again in class. But the answer we got was in Q4, but we want our answer to be in Q3, because 180 to 270 is in Q3. So I try to find what angle is equivalent to negative 38.682 degrees in the third quadrant. And the way you do that, again, is you look for symmetry. So notice how there's symmetry here. That might help, too, if you think about it that way. There's symmetry between those two angles, so we travel 180, then go 38.682 degrees to get the same thing. And if you were to actually take sine of 218.682 degrees and sine of negative 38.682 degrees, both situations will give you something close to negative 5/8. Let's try one more so you got it. So one more example for grins and giggles. Solve equation tan theta equals negative 5.3, where theta is between 90 and 180. So theta will equal inverse tan of negative 5.3. So use a calculator, inverse tan of negative 5.3. So we get this. Negative 79.315 degrees. So that will be in Q4. That right there is negative 79.315 degrees. Now we want to answer between 90 and 180. So changing colors, we would want something like that. So notice how we try to keep the reference angles the same. See how these here, symmetry or same theta ref. So we want the same thing over here. So notice how our angle is 79.315 degrees away from the x-axis for this angle. So the one in the second quadrant has to be the same way. But really what it's going to be, it's going to be 180 degrees minus 79.315 degrees, because we're going to go in standard position. So if I work that out, I should get 180 minus that would be 100.684 degrees. So this will take probably a little practice, and I'll probably put one or two questions on the Google Docs form, but that's how it goes. So that's it, and it looks like we are all set for today. All right, I'll see you guys on Monday. Have a great weekend. We got gorgeous weather today, so see you guys on Monday. Goodbye.